All right, I'm going to start again for part 2 of digital trace data, and I hope you're all caffeinated and sugared up. So first, before I start talking, I want to make a plug for I believe Taylor has put out a link on the Slack on proposing topics for dinner discussions. And
we're not doing well.
We're not doing well because we have only one that's been proposed. Although, yeah, although heads up, first tonight Roberto is going to be leading a dinner discussion on the ethics and the challenges involved with web scrape data or scraping web data. And he'll, of course, he'll talk about his personal experiences with that. But I know many of you mentioned, I recall from the lightning talks, had been talking about using web scrape data or are using it. And I think it would be a great opportunity for us to just have a discussion about some of the challenges you might have faced or some of the bigger pending issues. Yeah.
I think also Friday Charlie will be giving the workshop, and he had an issue with digital terms of agreement or something.
Yeah.
Made him waste 9 months of his life just to get a database.
Yeah.
Yeah. So he can help you with that.
I don't know if Charlie is in the building, but I might write him a message and ask him to join this. Yeah. Charlie, if you're watching the live stream, come to dinner. Anyway, so that's tonight, but it would be great. I mean, all of you are brimming with really exciting and interesting ideas or have just questions you want to discuss. And maybe your question is computational social science even a thing and worth it? And that's also a very good and legitimate question that we can have a discussion about. And I think that's the dinners are a great place to be able to do that for us. And we also will have some. So tonight, Roberto's already taken the slot, but we can also have 2 or 3 discussions going on at the same time if there is enough interest. So just please fill in that sheet that Taylor sent out. Yeah, there we go. The second, is there another?
There is a feedback form from yesterday. We got 4 responses. They're not compulsory, but they're really helpful for us, especially if we want to do this again and to inform other SICSS locations. We've all learned a lot from each other from these feedback forms, and it's just open-ended to questions. So there'll be another one tonight about today, and you can also go back and answer about yesterday if you'd like, but just keep an eye out.
Yeah. Okay, so dinner discussions. And also, if you're interested in any particular topics, there's propose the topics in the channel, right? And so please feel free to start channels to discuss these kinds of discuss things.
Just topic, and it's all sites.
Yeah.
So if you just write a word or a little description of what you're interested in, anybody who else is interested in that can like it, and then you have a sense and you can start your own channel talking about web scraping and things or whatever you want.
Yeah, exactly. Okay, great. So I'm going to start now part 2 of digital trace data, and the point or the purpose of part 2 of digital trace data is, so I've given you a kind of conceptual overview, talked a bit about how might social researchers use digital trace data for answering social questions in terms of different kinds of research designs, the strengths and weaknesses, and that was meant to sort of think very generally about this kind of data source. And now I'm going to talk a little bit about kind of tools and techniques that we might use for working with web data, not necessarily here just digital trace data, but web data. We might adopt some techniques such as web scraping or screen scraping. I'll also talk a bit about APIs, give the example of the Facebook marketing API, since I talked a lot about research involving the marketing API. And then we have a group exercise that I hope that we'll start off today, which will be first we'll start off more individually, and then in that I'll just ask you to work with an API individually, your API of your choice, or maybe the marketing API or something, the Twitter API. And then tomorrow in the morning, we're going to dedicate the whole morning session to the group exercise, just like we did today with ethics. Okay, so the different techniques and tools, and this again is not meant to be an exhaustive lecture of every possible way that you might want to deal with web data or all the APIs in the world, because there are more than 20,000 web APIs, so I can't go through. I mean, it's like saying that there are so many surveys in the world. I can't teach you how to use every survey in the world. but I can tell you general principles of survey research. So think of it in the same way, right? So web scraping is simply the process of automatically extracting data from web pages. Now this is perhaps familiar to many of you already, and because you've been doing some kind of web scraping already. The slides that I'm going to be using now just rely on Chris's tutorial on screen scraping, which is on the SICSS main page, the Princeton page, or the Princeton website. So if you want to follow and actually try some of the code yourself, you could just go to the tutorial and follow along if you're interested. Anyway, so as I said, web scraping is just, or screen scraping is just identifying a web page that you can legally, as you see on the thing, legally scrape, and then downloading the source code, which of course this is what a web page looks like to a computer. It's the HTML at the back end, or it could be an XML file, and then essentially parsing that source code to create a kind of data set that you can use. And I think before we kind of go further, it's important to take a sort of pause and say, is web scraping legal? And I've come to learn that there are a number of opinions about this, because there's website terms of service. Are you allowed to do this? And often if you read website terms of service for a lot of websites, especially large websites like Facebook or New York Times, they will actually say, no, you're not allowed to do this. You're not allowed to automatically extract data from, you're allowed to use it for individual use, like, you're allowed to read these things, but you can't just kind of systematically have a spider or a crawler just going around using these pages. But I've also heard views about how terms of service are not legally binding agreements, and as a result, this is not really a contract that needs to be obeyed. I personally, as a researcher, like to err on the side of caution. And I think, and that's, if people ask me, I always say I err on the side of caution, because you don't want to do something that might make things difficult for you, especially if if at some point it turns out that there is some contention about the usability of that particular data source. So there's no, I would say, general prescript here that I want to say, other than say, make sure you read and understand terms of services, and also yourself think about, in the context of what you are doing, is this something that you how does it fit in with your goals and your plans? All websites these days also tend to have a robots.txt policy that specifies rules about automated data collection. So for example, this is Wikipedia's robots.txt policy. I know Pablo here is an expert on Wikipedia, so you probably have seen this policy. Have you read it? No. Well, you don't have to read the policy, but because Wikipedia is okay with most crawlers, they're no kind of an open source, open encyclopedia. But of course, there are some web crawlers that they don't like, because it's observed spanning large amounts of, and ignoring rate limits, and it's disrespectful and so on. So as a result, some of these are disallowed. So even on Wikipedia, there are some bots, or there are some crawlers that are disallowed. So anyway, so most websites these days have these kinds of robots.txt. So you should, if you're planning to use some kind of a crawler, you might want to, crawler by crawler, I mean just essentially some kind of a computer program that is crawling or going through many different kinds of web pages and extracting information from them, usually quite regularly. And usually crawlers tend to work with they might have different kinds of rules, but one crawler might go to one page and then go to all pages that links to that page, and then so on and so forth. So it can quickly become a problem that is quite large.
Are you referring to a crawler as an agent that does the web scraping?
No, I'm referring to the crawler as the program, the computer program.
That does the scraping.
Right. So yeah, a crawler in this case here would be just the computer program that's going around collecting. But obviously, I assume it usually is designed by an individual or a team or something. So yeah. So these, for example, these crawlers here, most of the things that they don't like on Wikipedia tend to be advertising or media partners, Google, so on and so forth. Anyway, so this is a straightforward Wikipedia page. This is just the World Health Organization's ranking of health systems. And on this page, this is what the back end looks like. This is the HTML of this Wikipedia page. And really, so Wikipedia is actually, if there's like sometimes good information on Wikipedia, you might want some table from Wikipedia. And as far as scraping Wikipedia goes, it's like fairly manageable. It's quite an easier resource to scrape. It has generally the same structure, and the RVest package from in R. Have any of you used RVest? RVEST?
It's actually not being thoroughly maintained.
No, it's not being used. Yeah.
I mean, it switched to XML2.
XML2.
You can do pretty much anything that you do in
RVest. Okay. So Jorge is suggesting that better than RVest is XML2.
I mean, it's not necessarily better.
But it does the same kind of things, yeah.
I mean, I've seen like the author switch, so he's not giving much maintenance to this, but rather to XML.
Yeah. I mean, you can still use RVest was one of the most widely and is one of the most widely used still, I think, for doing simple static web pages. And you just would you would read the HTML page into your R window. It would tell you it's an XML document. This is what the output looks like for. If you just read the HTML, this is what it looks like for that object. And then, so you would then go to, so this is back to that web page. So this is open in Google Chrome. You would go to your developer tools here. And then in order to be able to scrape this web page, so assume that I want this kind of table on this web page. There's the table on the rankings. So say that this is the information that I want, right? I want this table is what I'm trying to extract information on. So I would just go and identify through the developer tools, I would go and inspect and find the XPath for this. So I would just go and copy the XPath where this table starts. And then it's quite straightforward. I would just go use this HTML_node command, and then I would specify the XPath. And as a result, I would be able to, and then using this HTML_table, essentially be able to extract that table. So this is a pretty easy web page to scrape with essentially 3 commands. Using this RVest package, we can import and pretty nicely analyze this table. Of course, most web pages are not Wikipedia, and they're not as straightforward to extract tables from. In my experience, often sites that have a lot of tables where you might want information, even if they don't have, they might not be they might be quite interactive and very difficult to extract information from, but often they'll have on some part of their web page, they might have a JSON file. And these JSON files, which is often, which is just, as I said, which I'll come to as well later, is just a data storage format with lots and lots of curly brackets, and it's often the way in which a lot of information is stored, especially on the web, and can be used using the JSON format. We might be able to collect a lot of this information that might be available on these websites somewhere, but at the same time, the tables directly might not be able to be scraped. So for example, for a project where I was interested in using the Global Gender Gap Report, the website is very interactive, was not easy to scrape, but actually somewhere hidden on their website, I just found all the tables in JSON, so it was much easier to use them that way. So it might be useful to see if on some kinds of data sources that you're interested in, whether there is that JSON file somewhere on the... Anyway, so for more complex pages, as I said, this kind of static, this simple code doesn't work. And then especially those would have like a lot of these style sheet, cascading style sheet CSS elements. So we might need other approaches. So we might use something called the selector gadget, which is this plugin you can put into Chrome, which then allows you to sort of point and click and find the parts of the page that you want to scrape. So for example, here, this is the part, if I, in the example, if I were interested in just getting this part, I would just kind of point and click on the different CSS elements, and then the selector gadget would kind of identify this for me. And similarly to what we were doing before, using again the HTML nodes, instead of XPath, now we'd specify the CSS, and then that would then be used to extract this information. We still would probably need to clean this data set because we would get some information, but the strings might be messy or they might not be in the perfect format. So there would still be processes in which we would need to do some data wrangling, but at the same time, that could be an alternative approach to also do some kind of web scraping if we wanted to. Anyway, in practice, this is web scraping can be messy, it can be difficult, and it can yield data that aren't always as straightforward to use. But again, this is problem specific. There might be, in some cases, that might be the only thing you can do. You have to just clean messy data, and that's what you have to do. But sometimes you have an alternative, right? And maybe Roberto might talk about this also in the structured, in the dinner discussion that we have. One approach, if you have a complex web page and you're interested in extracting information from it, you might want to outsource this to crowd workers, right? So you might want to use Amazon Mechanical Turk as a way to send people to different links and say, extract this information from this web page for me, and like put it on. So you might want to outsource it to on a crowd worker platform as a way to collect information from a web page rather than trying to automate the process. Another approach, of course, could be that you could use a web-based API if an API were available, because some websites do make their content available in application programming interfaces. Just by show of hands, how many people here have ever used or interacted with an API? Okay, so the vast majority of you have some experience using APIs already. Can I get a sense of what kinds of APIs you've used? At the back, maybe? Twitter? Directly or through an R package or something? Through Python packages.
Twitter and Facebook.
Which Facebook API?
The old one.
The graph.
Yes.
Yeah.
I used one for, I think the name was something about the genealogies, like you get like the genealogy of some names, so you can find out people's like gender or race based on like their yeah, and that one was a very like simple, and you get the URL,
Yeah.
the API, and then whatever content inside.
Yeah.
Yeah.
So we had, Kayla, what about you? I'm interested also, by the way, just because I think this is also an opportunity for you to know what other people have done, also helpful from the perspective of your projects. Yeah.
There was one that was set up by an Amazon Center developer called Smart Citizen.
Uh-huh.
And you could take other people's third-party data from sensors that were rapidly open around the city.
Excellent. Okay, so we have social media APIs, we have air quality, we have genealogies. Yeah.
I've actually used many APIs. It's so the live bicycle
Uh-huh.
information in Barcelona. Then there's the
Bising.
Yeah, Bising.
Yeah.
Yeah, they have a live
API.
feed, like every second when you change or move a bike,
Oh, wow.
it's actually recorded and you can. So yeah.
Oh, that's very interesting.
That's cool.
Yeah.
I actually built a sort of like an automatic bot to grab and build
Every
like a
time.
historical data of
Yeah.
bicycles. And then they have this massive for all public data in Spain for all different regions.
Open
of the
data.
world.
Open data.
Yeah.
Okay, so we have sort of transport and also a public API. Any other experiences? Yeah.
Google Perspective for ranking speech based on toxicity.
Ah. So what can you tell us a bit more about what it does?
It's mainly for detecting hate speech.
Uh-huh.
Toxic speech, and they developed it, I think, mostly for content moderation and for website users to go through comments and automatically tag some for moderation, and it's a great use of it. And, and they have they're developing algorithms to classify speech in a number of different ways. Hate speech was kind of the first one, but they're also looking at giving I don't know what all of them are, but all sorts of ways to score speech.
Yeah. So it's a data analysis API. Yeah. So that's also an interesting aspect here, because so far we've had a lot of APIs that are just you're retrieving information from them, but in your case is also doing some additional analysis, right? So it's analyzing info. So you can have APIs that are both, of course, storing, and you can collect information, right? You can pull information from an API, but you can also basically make a request to an API to analyze something for you. Which I think is also an interesting dimension here. By the way, I would also suggest for those of you who have talked about the APIs that you're using, if you don't mind, could you put links in the Slack so that other people also have a sense of what these APIs are? Yeah.
I have one also, it's called the Open Corpus API. And
Open Corpus.
Yeah, allows you to query any name of the firm.
Yeah.
To return which jurisdiction it's in,
Uh-huh.
side of the firm, and that kind of stuff. Also do some fuzzy matching. So the problem with a lot of firm names, that for example, you could have like N brothers or N sons, and it could be with a dot or without a dot, and then the matching goes awry, normally speaking.
Yeah.
It allows you to do some fuzzy matching automatically, so it connects them. So if you ever have data and you need to know firms that you mentioned and which types of firms and where they're from, you can use it.
Yeah. Okay. So that's global, or it's wow.
I would also add YouTube API.
YouTube API. Sure.
You can connect all the comments to videos. Even for some videos, you can connect the subtitles or captions.
Yeah.
All activity for YouTube channels.
Sure. And have you used that in your own work?
Yes, one of the projects.
You are
we
using it.
studying such thing as migration spark.
Uh-huh.
So yeah, we are studying which videos prevail in this discussion,
Uh-huh.
and most of them are right-wing. Yes, but this is not originally a right-wing topic.
Yeah,
But,
sure.
Our results show that most of the channels, most of the videos are related to some right-wing activities.
Right. So this is an example of, and the YouTube API is actually still quite rich, right, in terms of providing you a lot of information, and it has, as far as I haven't used it myself, but what is the credentialing process like? Is it fairly straightforward? Can you do it with anyone with a YouTube account, or do you need it? Yeah. And anyone else have any other interesting examples from their own work, or?
One
And
I think is the Google Translate API.
Google Translate.
You can very easily translate large amounts.
Yeah.
Of text.
Yeah. Me? We have some live stream issue that we're.
We can't tell much about
Yes. Okay, yes, thank you. Anyway, it's hard to be spontaneous and have a discussion while at the same time be. Anyway, so like the reason I asked all of you, in addition to this being a community sharing exercise, is to also illustrate that web APIs exist for purposes of data extraction and data analysis, right? So here's the translate, and this was the perspectives API. The other thing that's cool about them is that they exist for all sorts of domains, right? So we have social media APIs, we have APIs that are providing air quality data, we have genealogies, so we have really a range of, and they're also providing all sorts of when you do a kind of GET request to them and you ask to get some information, you can get information in all sorts of forms. Often you'll get some kind of a JSON array, which will be, with, as I said, this format where things will be text in lots of curly brackets with lots of these quotation marks, but at the same time, sometimes you can also get different kinds of format. But what is an API for those who haven't used APIs? is an API is simply a software intermediary that allows two applications to talk to each other, right? That is very generally, an API is just allowing for two applications to talk to each other. And like an example for this would be if you think about, for example, so in a web API more specifically, it allows a client or a computer to ask another computer, usually a server, for some kind of resource over the internet. So if you think about, for example, these aggregator websites that like Momondo or Expedia or Kayak, right? They themselves don't actually have the availability of flights on the particular date and all this information on their own systems, on their own servers. But at the same time, they still access that information and show it to you when you make a query to them. So how are those two websites interacting? Through an API. So there's structured bit of exchange going on between, for example, Momondo and British Airways when you make that query, and that's usually happening through some kind of an API, and that kind of exchange is then what you see there in what your final product is, that's been enabled through that API. What's cool about a lot of modern APIs is that they adhere to standards that make data exchange between them programmatically quite accessible, structured, and generally safe. And another thing that's, I think, kind of interesting and cool about APIs is that they generally require some kind of credentialing process, right? So they have some kind of key that you need or some kind of authentication process that you have to go through, which in some sense gives them more legitimacy than you would have where you were just sort of crawling or scraping a web page. So sometimes people like to draw a distinction between, an API-based data strategy versus versus one where you've just kind of scraped something off the web. You have a point, Roberto?
No, sorry.
Well, it's good to exercise, yeah. Okay, so that was my point about how the API, and really starting around the 2000s, when there was this whole development of standards and an explosion in web APIs, there was really an expansion in the number of APIs that are available. And this is a good resource, programmableweb.com/APIs, where you get a sense of all existing web APIs that are available for all sorts of purposes. And this has, according to Chris, this has about 20,000 and counting. And it tells you about all categories of APIs. And you see a lot of them were from the mid-2000s, which is when this kind of boom in APIs occurred. And now I would think we're sort of reaching a plateau where there isn't really kind of an expansion really that's happening at the same rate. And maybe, we don't know, but maybe there might even be, as I was saying earlier, a post-API age where there might be more challenges to data access. So most web APIs tend to use hypertext transfer protocol or HTTP methods, which you're familiar with because when you're making any query, when you type in a URL, that's kind of HTTP, that's how it starts with. And HTTP is the network protocol that delivers virtually sort of all files over the internet or over the World Wide Web. So HTML files, image, queries, everything. And the nice thing about HTTP methods is that there are these kind of 4 or 3, the get, post, delete, and a few other verbs that are used to interact and make requests with them. So I think 2 of the most commonly used ones are get, right? So get is used when you're requesting a page, and post is usually when you're like submitting something to a server or when you're submitting a form to a server. That's a kind of a post request. And the HTTR package in R is a great way, in my experience, to just work. It's very useful to work with all kinds of APIs. And you can make a request to a URL, get a response, and the verb for that is get, G-E-T. And the response usually contains a kind of, all responses will have a status, a header, and a body. So here, for example, I made a simple request. So this is HTTR. I just said get. I'll show you in the next slide what this is. But I said I made a request to this HTTP cat API, and then I queried and I said, what is it? Is it status code? And I said trial, and this is 200. And for those of you who've used, HTTP 200 means that this was a successful request. So 200 is a status code for success. And 400 is like bad, right? 400 is no, somehow something went wrong, you didn't get access, so 400 error, usually unauthorized or some problem, some credential, something's wrong. And then I just said, what is the content of this? And I get these kind of numbers because this is what this is, right? I made a query to the cat. And what's cool about this is that, so this is a joke, right? They have all the error codes with cat photos. It's the cat API, which has the, I don't know, anyone else seen this before? No, okay. They also have a dog API yesterday. So yesterday when I was having dinner, my partner said, why don't you have a dog picture instead? Dogs are cuter than cats. And I was like, no, I know the cat API. Anyway, so the nice thing about this is really what you see is that my point here to show you the cat API is first that it was a very simple command, but you're making a request to different kinds of data in different formats. So this is not a JSON object, but you got a cat. And that cat is an image. Anyway, so there's the Facebook marketing API, which is an example, again, of a social media API that I used some papers, and I described some papers that had used this. That's an example, again, of a social media API that we might want to use and could interact with using the HTTR package in R. And in order to do it, the credentialing involved is you need to have a Facebook account, you need to have the marketing app with token and add account number or act. So rather than opening my Facebook account here and showing you how to get these things, which would involve me also showing you my own credentials, I suggest if you want to get these credentials, Sophia Gill-Clavel from the Max Planck Institute for Demographic Research has very nicely and helpfully prepared a tutorial on how you can get these credentials, so I don't have to reveal my Facebook timeline and histories here. So I suggest you go here and link if you're interested in getting these credentials to set this up. But if you go, essentially, if you open your Facebook account, and this is perhaps a legitimate reason to open your Facebook account at this point in the lecture, if you want to, if you go up to the top where on the right-hand side, if you click, there's a little arrow or like a drop-down menu where it says marketing on or marketing platform. I don't know what it says. But if any of you have a Facebook account that you want to open and you want to see, on the right-hand side, there's a part where you can say advertising on Facebook is what it says. And if you go to advertising, if you click on that link, advertising on Facebook, this is generally what you get in the end, right? You make a few more next steps, and then this is what you get from that on the front end is what you see. And what this tells you is you can create a new audience here, right? And you can say, so yesterday night I created an audience, and so at the moment there's this Cricket World Cup going on, and I'm very excited about it, but I didn't watch it yesterday. I was very sad. And then I was thinking, I wonder if other people in Oxford are interested about the Cricket World Cup. And then I did a query request yesterday to see, what is the size of the audience that might be interested in cricket and the Cricket World Cup on Facebook. How many Facebook users are interested in cricket and the Cricket World Cup in Oxford and all. So I just said men, women, all between the ages 18 plus. And it turns out, according to Facebook, 38,000 people are interested in cricket in Facebook, which I was kind of surprised by. I thought it would be a lower number. So yeah, this is an example of basically making a targeted audience on Facebook. Now this is telling you how many users meet certain characteristics by geography, by age, gender, and there are actually a range of different other kinds of detailed targeting. This was just a very sort of casual request, just looking at interests. But you could also do this by things like parental status. So in the tutorial that I've prepared to accompany this lecture, which I think is also on the website for SICSS-Oxford, you'll see an RMD file where I link to some pages that have used this data source for research. And you can see that that they've used different behaviors or interest categories to create measures and variables with this. So this is on the front end. This is what it looks like, right? This is what the numbers look like. but actually programmatically we can make a query to this API to retrieve what are these ad audience estimates. These ad audience estimates are just the measures of how many Facebook users match certain characteristics. And you can do pretty detailed estimates, or you can do very aggregate estimates. So, but it's possible to obtain these programmatically using the marketing API. And what are these are essentially targeting specifications. You can specify what categories you want to target and get cell sizes or counts for. And this website, it's actually quite well detailed in terms of the information. It's very well documented, and it tells you how different things are operationalized. The one drawback, though, in my experience with working with this API is that it changes all the time. And you go through many versions very quickly, so that if you have a previous base URL that you used as a syntax, things change, and then the query structure changes, and then you have to essentially be mindful of that, or targeting specifications get moved around. So what used to be classified as an interest before becomes a behavior, and so then so old code might not work. If you had done a query, say, with an older version, it might not work with a newer version. Yeah.
And how do you deal with this in your gender project, which essentially does this every day, right?
Yeah. So the one way we deal with this is there's a person who works on the project, and when he notices something is wrong, right. But that's a really good point, and it's a really good question, and that's one of the reasons we actually hired someone for this, was because it became that if you want to do this if you actually want to do this kind of connection, or you want to have a platform or a dashboard that is actually doing this regularly, you need to be, you need to have someone who is dedicated to actually monitoring these kinds of changes, because otherwise it would not be. And even then, even when you have someone working on this, sometimes you don't realize that the changes occurred, and then you notice 2 days later that how the data weren't collected and why were they not collected. So yeah, it's a bigger, and actually this has been an issue. I don't know if others have had this issue, that sometimes things change and you don't know what changes. And sorry, yeah, go ahead.
Do you have to be buying advertising or spending any money on Facebook?
Yeah, good question. Yeah, so to actually launch the ads, you don't need to actually run an ad, you need money. But in order to query just the counts, you don't need to, it doesn't cost money. So if you were to run an ad, if I actually went and ran an ad for these 38,000 people in Oxford who are interested in cricket, then yes, I would be paying. But I just asked for the count, and that's free.
And they don't cut you off if you ask them to make counts back.
Well, all APIs have rate limits. And this is a concept where if you query too much too fast, then you are basically you're being disrespectful, and your access might be compromised as a result of that. But as long as so what rate limiting means essentially is that if you wanted to extract a lot of queries, it would take a lot of time. But rate limiting also means that if you do stick within the rules of the game, it's fine. There are also different levels of tiers that we found. So we were able to improve our status for digital gender gaps to go from I don't know what status tier officially it's called, but we went to a higher status tier, which allowed us to have a shorter gap between queries. And the reason we were able to do that was because we went through, again, an additional authentication process where we explained why we were collecting these data by making a little video about it. So that was an additional step to reduce the time between queries to 5 seconds, or I think instead of 8 or 9 seconds. So that's kind of a strategy that some might allow you to have. So yeah, these links are very helpful though in telling you, but the API keeps changing, and this is a problem that we've encountered. At this point for version 3.3, which is the version of the API so far, at the moment, this is kind of the general structure of the URL. It's graph.facebook.com/the version of the API, act, and this would be your ad account number, the delivery estimate, and the delivery estimate is basically telling you that it'll tell, it's what delivery do you want, what kind of estimate do you want. Anyway, and then you have to first authenticate yourself with a token, and that's the token that I was telling you. If you go to the tutorial that Sophia's prepared, you'll be able to see it, how to get those tokens for yourself. But again, we already discussed this. It's important to remember rate limiting when working with the APIs. I'll work through, I think, is the tutorial online?
The HTML.
Yeah, the HTML of this. Yeah, so I'll just go to that. But before I'll go to the tutorial next on the HTML file. But I just want to say that as a general principle, this kind of targeted advertising counts for how many users on a platform meet certain characteristics, right? This kind of online advertising data as a general principle is not just limited to Facebook. It also exists for Google. It also exists for Twitter, for instance. So this is an example of Google AdWords here. This is AdWords trying to start an advertising campaign. So these are, again, data available for advertisers. This is where I'm trying to start a new advertising campaign. And I'm saying create a campaign. And I've chosen gender, age, parental status, household income. This is only available for like the US household income as a targeting criteria. Or like US and a few other countries. Anyway, so what you notice here is, oddly, so I chose everything, and then you notice here that it says your targeting reach is 10 billion. Now I'm a demographer. I know that there aren't 10 billion people in the world. So why is Google claiming there to be 10 billion people, right? So like, what is the problem here? So it turns out that unlike Facebook, which gives you estimates of users, what AdWords is giving you is estimates of impressions. And impressions is vaguely defined impressions is defined in their documents as just how many times an ad would be seen by someone, right? So how many eyes would it encounter? And actually, in the context of our gender gaps work, this is interesting because I haven't included a figure here about this, but when we look at the same ratio of the Facebook gender gap, we find that the gender gap or gender inequality as estimated by a ratio of Facebook users, if we had a measure of digital inequality as measured by the ratio of female to male Facebook users, is actually much more optimistic about gender equality than the Google AdWords based measure, which suggests that there's a greater gap between men and women. And part of the story there could just be that, if men have more time on their hands for leisure activities, they might be spending it online, or they might be surfing much more online relative to women who might be they might have internet access, they might be using it, but they might not be using it as much, and as a result, the impressions they create are not as many. So even though the two measures of the Facebook gender gap and the AdWords gender gap has a very high correlation, generally for the same country, the Facebook measure tends to be much higher than it is for the Google AdWords gender gap. That's what we've been finding in our work here. And in general, we find that for when we're trying to estimate internet use gender gaps and validating against survey data, we find that Facebook does better on its own than AdWords. But the best models are those that combine Facebook and Google when we're trying to make a prediction about internet use gender gaps. Anyway, so what I'm going to do now is just run through quickly the tutorial on how to use the API from within R. Isn't this? By the way, this is the Digital Gender Gaps website, so you can see the reports for the different days. You can see different days, how it's evolved. You can also see how we're trying to estimate the mobile phone gender gap and so on. But, where is it, Here it is. Okay. How can I go back down with this? Can I take this here? Okay, so what I've done in this tutorial is just giving you an example of how to get estimates from the API, from the marketing API, using your R console. And you don't really actually need that many packages for it. You just need HTTR and JSON Lite because the query is returned in JSON format. And you would put in your token and your act. And as I said, the general structure of the URL that you're making a call to is quite straightforward: graph.facebook.com, the version, your credentials. And then the key information is going to be this targeting spec, right? So the simplest targeting spec here, so the targeting spec is specified as a JSON array. So you have to, you specify it in these kind of curly brackets, but I'm dealing with it as a string here in R. Although if you had a more complex array, you might not want to deal with it as a string, and you might want to, work with it as a separate JSON object and then import that into R. Yeah. No, good question. So Giacomo's question is, can you get historical queries? Can you go back in time and see how many users there were in the past? And actually, that's a big limitation. Say, unlike Twitter, where at least you could theoretically go back at least a few days in the past in the free access that you get to the Twitter API, and even longer if you had paid access. Although, I don't know, the standard REST API lets you go back, 7 days or how many? Yeah. 7 days or something. But you can get premium access and go back. And there are some places that have access to larger, the Firehose, I guess, who have access to older. This is a big limitation of this data source. That's actually one of the reasons why in digital gender gaps we're collecting it prospectively, because we're interested in looking at change over time.
I think that's the solution for a lot of people. If you're not going to pay for access in other ways.
But so if you pay, can you even go years and years back, or is it only a matter of days?
You can go years and years back. And there's also like certain universities and things that have repositories you can get access.
Yeah. So this is sometimes called the Twitter. Does anyone, are any of you active Twitter users? Active Twitter users for research. Because the standard REST API lets you go back a few days, but if in some universities you have access to what's called the Twitter Firehose, which is a very large sample of, I think, tweets ever, all tweets ever. Yeah, at MIT and at a few other universities, they have access to that. And that means that, and again, this is coming back to the point I was making in the first part, where one of the reasons why we've seen so much digital trace data research use Twitter is because Twitter has been actually very open, unlike other platforms that have been much less open. So I think, Twitter has past data, but this Facebook, not this. No, but that's actually one of the reasons why we're going forward in time, is to try and get around some of those. Of course, Facebook, I'm sure, has it, but it's a different issue. But yeah, so this is a very simple query where I've just said all people in GB, so in the UK, and I've just said, and if you don't specify any other targeting specifications, then you will, essentially, the others will be left at by their defaults. So in the documentation, it'll tell you what the defaults are for all of the other specifications. And then I've just created a list here where I've said, these are just some attributes that I want to specify in my query to the API, where I'm saying that I want to get a reach estimate. That's kind of my optimization goal. So I want to just see what's the reach of my ad, which is the equivalent of like how many people would see this ad, or what would be the audience size of this ad. I've also said, for instance, that this is method get, that's the get verb from the HTTP protocol that I'm just extracting, or I'm requesting this estimate. I don't want to make any changes to anything, so it's just getting it. And I'm saying this is a targeting specification, and that's my targeting specification. I just want to know how many people how many are Facebook users in the UK. And that's what, and then I make a GET request using the HTTR package. And then and then I say, tell me, and I just parse this content as text. Because as I said, the output is in JSON. And then this is what I get from it. I get a list. And then one element in this list is this data frame. And you can see that it gives you these kind of 4 columns. It gives you estimate DAO, estimate MAU, and estimate ready. Estimate DAO refers to daily active users. The estimate MAU is the monthly active users. And estimate ready just means that this was a successful request. So for example, if you were doing some error handling, which you might want to do if you were making a range of requests, you might want to check if this estimate ready is equal to true or not. If you wanted to just confirm that you were actually getting plausible request. This is another issue we encounter a lot, is we get a lot of implausible requests. We get a lot of, so for example, we get a lot of thousands. And we know that, for example, the population of the US doesn't have 1,000 Facebook users. And 1,000 is generally the smallest cell count that they're willing to reveal information for the monthly active users. But at the same time, 1,000 can also just be sometimes thrown up as, it doesn't happen that much, but sometimes it happens that we get unexplained thousands, even though in the same country the previous day it was not 1,000. So it seems to be some kind of an error. And I've talked with others about it, and they feel that this happens, but it doesn't happen that much, but it happens enough that you should have, if you're doing a lot of queries, you should probably think about that. Another thing you might want to do is, of course, is again to go back to HTTP status codes. You might want to check if HTTP status code equal 200. So was this a legitimate, and was this a successful request or not? If you were just trying to collect a lot of queries and wanted to make sure that you had successful requests. So this was just, as I said, it gives you the DAO, the MAO. We might want to make a more complex query. So here I said age, I put age minimum, max. So I said I want a query which is GB and Spain. So UK and Spain, and only women in GB and Spain between the ages of 20 and 55. So that was my query this time. And I also said those whose location type is home. So Francesco was mentioning this yesterday. They allow you to specify whether you say you live in this place and you're actually living, or alternately you might be commuting from somewhere else. So there are basically different location types that you can also specify. So these are people who are essentially say that they're living in Oxford, and they're also being seen as basically based in Oxford. So this is kind of this home measure. Then the device platforms, mobile and desktop. So I put in some more specifications, but the query structure is exactly the same, just the JSON array becomes a little bit longer. And then I see that I get 42 million users. Or maybe, I don't know if this is updated. Yeah, 42 million. Oh yeah, I guess it's only women, so it's fine. I was like, this seems kind of small. 42 million for women, 20 to 55, GB and Spain. Another thing to note here is that by default, targeting specifications is an AND query. So it will not tell you GB or Spain, it will tell you GB and Spain. So if you wanted to get to know GB and ES separately, you would have to make 2 separate requests. And as a result, that's what I was saying, that if you wanted to make a series of requests about different countries, you would just have to do this in a loop, and make sure that in your loop you would put in, to avoid getting rate limited, maybe sys time, a certain number of maybe 8 seconds if you're in the first year of this. So this is so another aspect of this API, which is quite useful when you're working with it, is that you have, so this is the actual get. So this is actually when you want to extract the estimates. If you actually wanted to see what are the targeting criteria that are available, you could use the search API of the marketing API. And this, what I've done here is I've just said, so using slightly different URL, where I've just done search. Here I've said, tell me the ad targeting categories of behaviors, and this is my token, and then tell me what's available in these behaviors, and you see, so this is just the list of the first 10 behaviors of the 300 that come in this table. So you can see that you can target by frequent travelers, technology early adopters, interesting, Facebook access OS, Mac OS, Windows XP, anyway, so device types, these kinds of bits of information. Anyway, so this is just sort of a way that you can start if you wanted to extract some data from it. But again, there are many different APIs for many different kinds of things. This is just an example of one that I've used that's being used, for example, in this is the API that's being used for this digital gender gaps work, right? This is the data source that we're using. And so to come back, so for the next maybe half an hour before we go for dinner, I thought maybe we could just work on, if this would be our exercise for the afternoon, would be familiarize yourself and obtain credentials to work with maybe one of either the Facebook marketing API that I just talked about, or potentially the Twitter API, for which you can interact directly through an R package. And Chris has a very helpful tutorial on how to use the R tweet package, which is linked here on the slides, but is also actually I can test if it's linked on the slides. Yeah, it is. Look, okay, it is linked on the slides. Or you can also just use it in some other way. I should note that Pablo Barbera, who's going to give a talk here on Monday, has also said that he'll talk a bit about his own R packages, because he's developed some R packages to use Twitter in R, and he'll give a demo of some of his packages on Monday as well. This is a different package than his package. This one is, I think, by Mike Kearney, who's also a good package, or another API of your choosing. So just for the next half an hour, if you wanted to work on just familiarizing yourself, get credentials, and then maybe do some, especially for those of you who have never worked with an API before, just get familiar with working with one for the next half an hour, because our plan for tomorrow is, I don't know, should we make the groups now, or we did in the morning, yeah. But then I reveal the strategy for how the groups are made.
Oh, those.
Yeah. Well, okay. Anyway, so this is going to be the group exercise that we're going to work on in the morning. Divide yourselves into groups by counting into 4, which is why, because they didn't know about this, so it's kind of exogenous. Yeah, now they might strategize with those. Anyway, so I want you to divide yourself into groups, so groups of 4, and then work together to identify a research question that you believe could be answered using one of these 3 sources of digital trace data. So there are many different sources, but I just want you to think about anything that could be done with one of these 3, and think about it in the context of what question you could ask, but also think about research design, given that some of them have some strengths, some limitations, and then try and collect some preliminary data to test the feasibility of being able to answer your question, and think about how it could potentially be improved by some kind of hybrid design. So this is what we're going to work on tomorrow. Let's just sort out the groups at this stage so that there's no strategizing about this later. Yeah, and then we can also discuss the topic more at dinner. So Giacomo, do you want to start off by saying 1?
1, 2, 3, 4, 5.
No, 1.
Today in the morning was today we had 5 groups.
How many are we?
We want to have groups with 4 people.
I mean, what's our total number? I mean, I don't know, is there going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm very confused about who I'm counting.
Go with 5.
Go with 5? Okay.
Then 5.
Okay, 5. Yeah.
3, 4, 5. I can't be here.
Okay, so then those who can't be here, you have to. The auditors are not counted. 5.
2, 3, 4, 5.
And then we have some who haven't counted. You counted? 1? You can't make it. Okay, 2. So we have a shortage then. We have one group that is only 2, and the rest that have, yeah.
There should be 4 groups of 5. Are there not? 5.
Okay, but or we can just have. Can we just have some groups that are 5 and just some that are 4? Because we can't evenly spread, because there seems to be, yeah. Okay, so group number 2, arbitrary, group number 2, could one of you, could the second person who was group number 2, that's you, will be in the group with the 2 who are unclaimed.
Like 2 people that are claiming those 2.
Yeah.
But that's part of the other 5 people. The other 4 people who said it.
Ah, so they're fine. We're fine then. Okay, then we're okay. So there's just some groups that are 4, right? That's fine then. Okay, my problem is less complicated than I thought. Okay, good. Perfect. So that's what we're going to work on tomorrow. This is going to be the question. You might want to interact with your group, and so that we have group 1, group 2, group 3, group 4, and group 5. That's going to be the agenda for tomorrow. But for the agenda until about 5:15 or maybe 5:30 is this. Yeah. It's on the website. No, this markdown thing is on the slide. This one. It's on the website. It's called tutorial. Yeah.
I think the link to the art tutorial doesn't work.
To the what?
To the art tutorial.
It's not working?
I think
Okay, I'll show you where it is though. No, this is for the art weed. So for that you would just go to the Summer Institute. Go to the Princeton's page. And this is the link for it. So it's this one. So this is the Twitter. So this is using our tweets. Otherwise, if you prefer using Pablo Barbara's packages, I can show you his. Did you see it or this? It's called Application Programming Interfaces in R.
But the link to it is just called.
Should I can put it on the Slack maybe. I'll do that on the Slack.